Hey everyone, this video is all about solving proportions. This is for anyone that feels comfortable setting up proportion and then solving for that unknown using the proportional relationship, seeing if there's a nice number between our known values, in this case, the 4 and the 5. This is going to be the next level where there's not a nice proportional relationship, and we actually have to solve by isolating the x. So that's what today's video is about. So like I said, whenever we're solving proportions, we want to look to see if there's a nice relationship between our known values. Is there a nice number that I can multiply or divide 5 to get to 4 or 4 to get to 5? And there is not a nice number. There is a number, but it's not very nice. So when that's the case, when there is no relationship, we need to isolate that x. And we're actually going to use the same steps that we've used for solving for x by getting x by itself, by isolating that x. So in that case, I'm going to look at this right side here, and I'm going to try to get x by itself. Now, we've been using the fraction bar to show a ratio, but really what that fraction bar is saying is divide. So I can look at this problem and say x divided by 4. And that's going to help me do with the opposite operation, which is how we're going to isolate that x. I need to figure out what is the opposite operation of division, and I need to apply that to this side of the proportion. And I know that the opposite operation of division is multiplication. So I'm going to go ahead and multiply. I'm going to use parentheses and multiply that right side by 4. And I'm going to expand this out a little bit. Because this is fraction form, I'm going to say it's 4 over 1. 4 and 4 over 1 are the same thing. And what I really want, I made that into a fraction because this is like a fraction problem. So I want my values to match. So by multiplying by 4, my 4s are actually going to cancel each other out using cross reducing. And I'm left with just x all by itself on the right side of that equation slash proportion. But as always, if I do something to one side of the equation, I have to do that same exact thing to the other side, or else my equation will become unbalanced. So I'm going to go ahead and multiply by 4 over 1 on the left side as well. So I got x by itself from the right side. But over here, I've got to clean this up. What I've done is basically created a multiplying fractions problem. And we know from our study of multiplying fractions, all we need to do to simplify this is multiply the numerators together and multiply the denominators together. So 4 times 3 is 12, and 1 times 5 is 5. And I'm left with that fraction there. 12/5 is equal to x. Now, we want to clean this up, and we actually want to get this into decimal form. We could turn that into a mixed number, but we want to make it really exact around decimals because decimals are going to be more helpful in this situation. So I'm going to treat this like another division problem, and I'm going to say 12 divided by 5, and I'm going to get some value to figure out for x. So a lot of these problems end in a division problem, where the numerator goes in the box, the denominator goes outside, and I just need to do some division here. And I can tell that I'm going to have to add a decimal point and at least 1 0 to figure out this exact value. So 5 doesn't go into 1, it goes into 12. 2 times 5 is 10. Subtract, I got 2 left over, bring down the 0. 5 goes into 20 4 times. And I am done because I have nothing left over, nothing to bring down. So x, in this case, is 2.4. That's the x that if I plug in back up here, I will end up with equivalent ratios. And I'm basically solving for x. I'm solving for the proportion here by figuring out what x needs to equal. And that in this case is 2.4. Let's do another one. Maybe you want to give, if you're feeling good, give this one a shot, pause the video, see if you can figure it out on your own, but I'm going to go ahead and show how to do this one. Now this one, the x is over here on the left side. That's okay. We always want to start when we're solving proportion to see if there's a nice number between our known values, in this case, the 3 and the 20. Is there a nice number I can multiply the 3 by to get to 20? There's not. If this was 21, we can multiply by 7, but it's 20. So we forget the proportional relationship. We need to isolate this x by using our steps for solving. So again, x is being divided by 3. So I'm going to multiply by 3 with my parentheses. And again, I'm putting it over 1 to keep it in fractional form. In this case, my 3's are going to drop out, and I'm left with x all by itself. But because I multiplied by 3 on the left side, I got to multiply by 3 on the right side. So I'm going to go ahead and do that. And I'm left with a multiplying fractions problem on the right-hand side. I'm going to multiply my numerators together. 11 times 3 is 33. 20 times 1 is 20. And now I'm just left with an improper fraction that I need to turn into a decimal. And I'm going to do that by dividing the numerator. The top number always goes inside the box. 33 is going to go inside the box. I know I'm going to have a decimal in this problem because I know that 20 doesn't go into 33 nicely. 20 goes into 33 one time. 1 times 20 is 20. I got 13 left over. Bring down the 0. 20 goes into 136 times. 6 times 20 is 120. Yes. Subtract. Bring down. Subtract, I got 10 left over. I'm going to add another 0, bring that down, and 20 goes into 100 5 times. 5 times 20 is 100. I got nothing left over, nothing to bring down. So x in this case is 1.65. And there is my answer to solve this proportion. What value does x need to be to make this proportional on either side? 1.65. Last one, solving for proportions here, trying to figure out the value of x. Well, let's look for a proportional relationship. 2 and 5, there's not a nice one, so I got to solve for x. But what's different about this problem is x is in the denominator. When x is in the denominator, it makes it really hard to solve for x. So what we're going to do is we're going to actually use the reciprocal. Our idea around reciprocal, where the numerator becomes the denominator and the denominator becomes the numerator. And that is going to magically put the x up in the numerator. We want the x to be in the numerator because it's really easy to isolate in that way. But I can't just change a problem without doing that same change to the other side of the equation. So what I'm going to do is actually do the reciprocal of the left side as well. And this is going to turn into 3/2. My numerator became the denominator. My denominator became the numerator. Everything got flipped on its head, and I'm end up with 3/2 instead of 2/3. Now, in this case, I've got x in the numerator, and I would solve in the same way that I solved the first two problems. That's it for now. Thanks for watching. Bye.